The subject of ray diagrams, which has been causing a lot of trouble, I've noticed, and look at it from an exam point of view. Often when we're thinking about our preparation for the exam, we need to sort of think, what's going to come on a question, and how will I tackle it? Okay. In our lessons, we've dealt with 4 different scenarios. We've got the case where we're at an object which is very, very far away, which produces an inverted and diminished image, which is real. We've got the one at 2f, which makes an image which is the same size as the object. At less than 2f, which is, again, inverted, real, but this time much bigger. And then we've got case number 4, which is the kind of interesting one, the tricky one, which is the virtual image, as in the picture that you can see here. So what I thought we'd do is I picked 4 questions at random. I just wanted to see what kind of things come up when we look at doing ray diagrams in exams. Okay, so here's the first one. It should just be coming up just now. Here's the first one. Basically, we have the same thing over and over again. We've got the position of a converging lens, principal axis, object O. Okay, and we're being asked to complete the ray diagram. Well, we do our usual thing. We draw a parallel ray, which goes through F, the focus. We draw another ray, which this time goes to the center of the lens. And this time we've got a call to make. We ask ourselves, well, will these rays ever meet? Clearly no, because they're diverging. If they're diverging, we have that extra step to take, which is to kind of extrapolate out our lines. In fact, almost like we're working backwards, to see, well, where does it look like those rays have come from? As in, what are we, what kind of a lens are we looking at? Clearly here, we've got the formation of a virtual image. Okay. I want to sort of just talk a little bit more about what this means. Okay. The concept of a virtual image is quite confusing for students. And I think it's worth thinking about this, that when we look, say, for example, through a lens, then our eyes also have a converging lens in there as well. Okay, so if we're using a magnifying glass, for example, then these rays will arrive at our eye. Now, I've put a little eye in there. Obviously, my eye needs to be in a slightly different shape. But these rays now need to be focused. So inside the eye, that lens is going to do the job for us. And that's how this virtual image is created. So our eye does a little bit of work for us. It goes, okay, where did those rays come from? It focuses those rays at the back of the retina and allows that image to be produced. I'll state again that what it sees is what it thinks is behind the object, a big thing behind the object, which is actually a virtual image. Okay, let's get on to the next one. Now you notice here, in this case, we are inside the first focal point. Okay, we're inside the first focal length. Let's have a look at the next question. Well, this is exactly the same, except we're on the other side of the lens. In this case, our object is on the right-hand side of the lens. Well, objects can be on left and right-hand side of the lens. Okay, and so there we just do exactly the same thing. We take our line and we make it parallel to the axis, and about halfway through, I'm not very happy with the way I've done that one. I would redo that slightly. I think my second ray is not very well judged. Okay, the one that's also not very well judged is this one. Now, I think that this exam question is quite hard because usually we would draw that second ray going straight through the lens. Okay, don't worry about that too much. Okay, what I really hope you're noticing is that it's exactly the same thing again. Our rays don't meet. Virtual image, which is enlarged and forming behind the object. Okay, and so in a case of looking at those different situations, d greater than 2f, etc., 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 it's very much 2-0 to the magnifying case. We've seen 2 questions already picked at random, which are showing the use of the lens as a magnifying glass. Okay, let's look at one more. Oh look, we've got exactly the same situation again. We're going to get bored of this, aren't we? Okay, precisely the same thing inside of F, so 3-0. Okay, so what I hope you're getting here is that I suppose when exam questions are being set, we're very much relying on the fact that students find this kind of this lens quite difficult to deal with, and that's why these are coming up again and again. I suppose the other tricky thing is that we're dealing with an object which is not on the left-hand side of the lens, but which is on the right hand side. But then that's okay. The rays of light will still do the same thing. We're just looking on a different side of it. Let's try number 4, because at least number 4 is going to be a little bit more interesting. This time, this is a harder one, okay? What we're trying to do here is find out essentially where the lens is. All right, now if you look at this one, we've got an object on the left and an image on the right, and we've even drawn the little eye to show that the eye is going to be doing some looking. Okay, well, this image has been formed by a lens. All right, and it is clearly an inverted image. Okay, and well, in order for it to form on that side of a lens, imagine there's a lens in the middle there. Imagine this image to form on the right hand side of the lens. Then we can do a little bit of working out. Okay, every time we draw a ray diagram, we draw one ray which goes through the center of the lens. You'll notice it crosses from the top to the bottom, in this case from right to left, but in this case from left to right. So we can draw a line directly connecting the top of the object to the top, or well, in this case, the bottom of the image. Well, if that line is passing through the center of the lens, then that means that my lens is somewhere here. Okay, now actually the exam question in this one wasn't necessarily to say where is the lens, it was saying draw some rays, okay, complete the diagram. So we need to complete it. What we can now do, we can draw our parallel line, and then we can simply draw a line going through the optical axis to the top of the image. And this is quite nice because it allows us to identify where F is. This is the focal point of the lens. All right, well, obviously we cross the axes every other time at the focal point, and so therefore that point must be the focal point. Now, if there's a focal point on the right-hand side, then there's clearly a focal point on the left-hand side, which is an equal distance. Why have I bothered with this? You could stop here, but I thought, well, I kind of like these things, so I thought I'd play around with it a bit more. That must mean we can draw our third line, which goes through the focus on the left-hand side and then becomes parallel. And you can see there, give or take a bit of kind of jiggling around, my lines are crossing at the correct point. It shows we're forming a real image, which is inverted and magnified. Now, if we just have a quick look, well, my object is now outside of the focal length. And this means we're not using our magnifying glass. This is the use of our lens in a situation where we're getting a slightly bigger image. So we're kind of between that 2F and F distance. So if we're considering, again, what we found, 4 random questions, folks, 3 of them were magnifying glass lens, and 1 of them was a tricky real image ray diagram. So I hope that's showing you at least the kinds of things you might expect. Okay, I'd say that this last question is a very difficult one, but it's one that you're more than capable of doing if you just follow those rules about drawing the lines which connect the top of the object to the top of the image. As ever, please do let me know if there's anything that you don't understand about this, and I'm happy to help. Thanks for watching.